The universe is 13.8 billion years old. Our galaxy holds 400 billion stars, and by the most conservative estimates, roughly 400 million worlds where life could have emerged, many billions of years older than Earth. The math does not suggest we should have found someone by now. It demands it. Yet every instrument ever pointed at the sky returns the same answer: nothing. What could silence 400 million civilizations? Every number in astronomy is an act of understatement. The Milky Way alone contains more than 400 billion stars, so many that counting one per second would take over 12,000 years. Among these, even the most cautious estimates concede that at least 400 million planets orbit in the temperate zones where liquid water could persist. Not 1,000, not 1,000,000, but a number so vast it strains the mind. 400 million possible homes for life scattered across a single galaxy. And the universe has run this experiment not once, but for 13.8 billion years. Ample time for not just the birth of life, but for intelligence to rise, fall, and rise again. Suppose just one civilization gained a head start of 1%, an extra 138 million years. The physics of colonization are merciless. Even slow-moving probes, advancing at a mere fraction of light speed, could sweep across the entire galactic disk in 10 million years. That's not a theory. It's the result of basic math and the speed limit set by nature itself. Multiply these odds by the hundreds of millions of potential starting points, stretched over billions of years. The conclusion is inescapable. If the universe plays fair, we should be surrounded by signals, artifacts, unmistakable footprints of those who came before. Instead, we get only silence. What force could erase the echoes of so many possible voices? In the summer of 1950, over lunch at Los Alamos, Enrico Fermi leaned back in his chair, sandwich in hand, and asked a question that would haunt physics for decades. Where is everybody? The witnesses, Murray Gell-Mann, Edward Teller, and Herbert York, remembered the moment with an odd clarity, as if Fermi's words had cut through the chatter and left the room colder. It was not a grand pronouncement, just a quiet calculation. The stars are old, the galaxy is vast, and if life arises easily, intelligent neighbors should be everywhere. Yet the skies stay silent. Fermi's query was not born from science fiction or idle speculation. He had been running numbers in his head, weighing the age of the galaxy against the time it would take for even a slow-moving civilization to cross it. The logic was merciless. If the math held, the absence of evidence was not just puzzling, it was a warning. Years later, others would give this puzzle a name: the Fermi paradox. By the early 1990s, scientists began to call it the Great Silence, a phrase that carries the weight of both expectation and dread. It is no longer just a question for physicists at lunch. It is the riddle at the heart of modern astronomy, and it refuses to let go. Distance offers little comfort. The Allen Telescope Array has already scanned 500,000 star systems, casting its net across the quiet dark between 1 and 10 gigahertz for over a decade. Breakthrough. LISTEN has gone further, targeting nearly 1 million stars with a sensitivity sharp enough to catch a transmitter less powerful than some airport radars, if it were broadcasting from just a handful of light years away. Yet, out of the hundreds of billions of possible homes, these surveys have managed to probe less than 1/100% of the galaxy's volume. The silence is not explained by the vastness, it is something else. Some insist that aliens simply are not interested, that no one is broadcasting, or that they communicate in ways we cannot imagine. But if even a tiny fraction, just 0.1% of civilizations produced accidental radio leakage like Earth's, the statistics say we should have intercepted a signal by now. Instead, detectors register only the hiss of the cosmic background, an endless null that grows heavier with each passing year. SETI's frustrated investigators keep expanding their reach, shifting frequencies and widening the search. But the numbers do not lie. The comforting stories collapse under the weight of the data. If the universe is crowded, its inhabitants are either hiding, gone, or something stranger still. So what is left when every easy answer fails? August 15th, 1977. The Big Ear radio telescope, stationed in a quiet Ohio field, swept its gaze across the constellation Sagittarius. For 72 seconds, the instrument registered a narrow, blistering spike at 1,420 megahertz, the frequency of neutral hydrogen, the cosmic watermark. Jerry Amon, an astronomer on duty that night, stared at the printout as the numbers climbed off the page, peaking 30 times above the background. He circled the spike and scrawled a single word in the margin: "Wow." No one heard anything like it before or since. The signal never repeated, not over the next 78 days of nightly checks, not in the years of follow-up by MIT's Haystack Observatory, not in the decades of digital reanalysis. The coordinates yielded only silence. The frequency drift matched what you would expect from a source moving with the stars, not a passing plane or a stray satellite. No known terrestrial interference fit the pattern. It was as if, for just over a minute, something had called out across the void and then vanished, leaving only a faint pencil mark and a question that refuses to die. What did we miss? And if something was there, why did it only speak once? Project Blue Book, the U.S. Air Force's official investigation, ran for 17 years and logged over 12,000 aerial phenomena. Its final report, filed away in 1969, admitted that 7%, more than 800 cases, remained unexplained. Some of these involved radio frequency spikes and electromagnetic disturbances that did not match any known aircraft or weather event. The documents are precise, but the gaps are obvious. Later, the Advanced Aerospace Threat Identification Program collected 200 hours of classified radio data, flagging 15 incidents with spectral profiles that could not be explained away. Internal memos used phrases like persistent anomalies and unknown source. The UAP Task Force's 2021 report listed electromagnetic events with no terrestrial explanation, but the underlying data stayed classified. Across the ocean, a Soviet program in the 1970s cataloged 200 unexplained radio bursts. 12 showed frequency drifts suggesting movement. These files, too, were shelved. Occasionally, a retired analyst or scientist hints at hidden catalogs and unreleased signals. The official stance never changes, but the archives suggest otherwise. Liu Cixin described the universe as a dark forest. Every civilization, he wrote, is a silent hunter, moving carefully through the shadows, listening, never calling out, for the sound of another's presence. In this forest, survival belongs not to the bold, but to the quiet. The logic is brutal, but it is not fiction. Game theorists have shown that in a cosmos where intentions can never be proven and the cost of a single mistake is extinction, the safest move is silence. A Nash equilibrium of mutual fear, everyone hides because any signal could be a death sentence. Yet for more than a century, Earth has been leaking radio waves into the void, television, radar, And in 1974, the deliberate Arecibo message, a narrow-band pulse with enough power to be picked up 70 light-years away. Each broadcast, accidental or not, expands our bubble of detectability, a growing sphere that announces our presence to anyone listening. We have become the loudest voice in a forest that punishes noise. If the dark forest logic holds, then the silence around us is not an absence of life, but a warning, a universal hush enforced by the fate of those who spoke first. What if the only lesson is this: those who make themselves known do not last? Somewhere between the numbers and the silence, a new idea takes shape. The Great Filter. It is not a wall we can see, but a probability that haunts every planet. The chance that life, even if it starts, never makes it far enough to leave a mark. Statistically, the odds are cruel. For every world that could cradle life, the chance of reaching a technological stage that lasts is estimated at 1 in 10,000, or even 1 in a million. The filter is not a single event, but a series of evolutionary bottlenecks. Molecules that fail to self-organize, cells that never learn to cooperate, species that destroy themselves before they can look up and wonder. If this filter is real, then the silence is not just absence, it is a graveyard. Every null result, every empty frequency, is another tally in a cosmic mortality rate. What if we are not hearing others because almost no one survives long enough to be heard? Infrared surveys sweep the sky for the telltale glow of Dyson spheres, vast machines that would harvest a star's energy and spill waste heat across the cosmos. The WISE mission cataloged hundreds of millions of sources, but every candidate faded under scrutiny. Not a single star in the Milky Way shows the excess warmth of a civilization that has mastered its sun. No great works, no cosmic engineering, just the ordinary glow of dust and gas. If even a handful of advanced societies had survived and built on a planetary scale, the evidence should be everywhere. Instead, the data return a perfect null. Survival curves drawn from human history offer no comfort. The best estimates give a coin flip chance, 50%, that a civilization like ours will self-destruct within 200 years of gaining global power. The silence may not be an accident. It may be the echo of a pattern. Civilizations rise, broadcast, vanish. The darkness is not empty. It is filled with the ghosts of those who failed the test. And now, with every transmission, we wait to learn if we are already among them. Tonight, our telescopes still scan the dark, and the numbers remain unchanged. Billions of worlds, infinite silence. What survives the filter, curiosity, or caution? If the answer is written in the static, will we recognize it before we vanish? Sometimes, the most dangerous message is the one nobody sends. Share your thoughts below.